Okay, so what I'd like to talk to you about today is how we can use scatterplots as a way of representing two variable data, and how we can use least squared regression lines or lines of best fit to start to get insight into the pattern of data and maybe make predictions and hypothesize about relationships. Okay, so what we have here, I titled this those poor manatees, poor gentle manatees. Manatee is a very gentle animal, kind of floats just below the surface of the water, lots of them in warmer climates like Florida and so forth. Fortunately, they're tough to see when boats drive by, and often boats will strike them, and the propellers of the boats will often cut into their backs and often kill them. We have here our data for a few years going back from 2006 through 2012. So, for example, if we look at this first column here, what this is saying is in the year 2006, there was approximately 1,050 boats registered in a small area near part of Florida. And in that same area, we saw 88 manatees die from collisions with boats. And then you can see the general trend as the number of boat registrations slowly climbs. It looks like the number of manatees killed slowly climbs. So the question is, let's learn how to create a scatter plot and see what we can learn from there. Okay. So we're going to go to our TA84. Now, I already took the time to put the data into the calculator. And what I'm interested in here is how the number of boats registered is related to the number of manatees that die. I'm going to not concern myself with the year for the time being. So you'll notice here in list 2 I have the number of boats registered, and then in list 3 I have the number of manatees died. So what we're going to do is create a scatter plot. So to do that, you do, once the data is in here, just remember that our list 2 has our boat registrations, and list 3 has our number of manatees that were killed. We do second y equals, which is stat plot. We hit enter, and we want to turn this plot on. So when the word on is highlighted, we hit enter one time. There are 6 types of plots to choose from. We're going to select the first one. And now we got to remember what we said before. Our X list is going to be the number of boats registered, and that's in list 2. So we do second 2. That changes that information to list 2. And our Y list, number of manatees killed, is in list 3. So second 3. Do that. And that's all you need. The down arrow, you can select it. Maybe if you want to have a plus sign for a mark, you can do that. Press zoom 9, and we'll have a look at our data. Okay. So when you look at data, you want to discuss 3 things. You want to talk about the direction of the relationship. You want to talk about the form of the relationship and how strong you think it is. All right. So when we talk about direction, the question is it positively associated or negatively associated? And this is a pretty simple concept. All that means is if we have something that's positively associated, and that implies is as x goes up, y goes up. Now, as you mentioned earlier in class, often the x variable is called the explanatory variable. Okay, and this is the variable that we think might be having an effect on the y variable, which we discussed in class is called the response variable. Okay, then let's go back to our scatter plot. Oh, we should say one more thing. There's also negatively associated data. Sometimes that can occur. And when something's associated negatively, all that means is as x goes up, y goes down. That didn't happen here. It looks like as x goes up, y goes up. You can see that if you notice that we move in this general direction on our graph. You notice that our y values tend to get higher. We would say this data is positively associated. In terms of the form of the relationship, is it linear or not, this is what we consider data that's pretty linear. You can see that if you try and draw a line of best fit through the data, there you go. That works pretty well. It goes close to all the points with very little error. You see this one point here. There it is. I'll circle it in red. This point is sort of the furthest away from the line. Well, that could be just the way I drew the line. We'll let the calculator do it for us later and see if it gets any better. And then lastly, do we consider this to be a strong relationship? You're just getting a sense of this now, but this is definitely considered to be a strong relationship because these points are really close to the data points that we have. All right, so the first thing that we want to do is we would like to answer some questions about this. First thing that we're asked to do is create a scatterplot. It says here, create a scatterplot and comment on the direction, form, and spread of the data. We already commented on those things. We're supposed to accurately reproduce this, so I'm just going to make some comments about how you do that. One thing you should do is take a look at your window. So for example, if I press the window button here, I can see what X min is and X max is and Y min and Y max. You should copy those down and make sure you label your axis accordingly. Okay, let's go back to the graph. I'm going to cheat a little bit here. I'm going to copy that picture onto our notes so we have it. And there we go. That's what it looks like. Keep that in mind. We'll come back to it in a little bit. Okay. The next thing we're being asked to do is find the least squared regression line. How does this equation confirm or refute the thoughts about the directional relationship you stated in your answer to question 1? Okay. So the calculator again can help us here quite easily. Just need to know the correct steps. If you press Stat in the middle, you get a menu for Edit, which you've already used. Hit the right arrow, you go to Calculate. Then I want you to press number 8, which is linear regression. All right. Linear regression expects us to tell us where X is and where Y is. So we can do that by doing second 2, because that's where the boat registrations were, comma, which is above 7. It's a key by itself. Second 3. Okay? That's where the number of manatees killed are located. And comma one more time, we're going to press vars, y vars, and function, and y1. We do that last step because we want the calculator to take this equation and put it into y1 for us so we can see it overlaid on top of the data. So I'll hit enter, and I'll get the information. So what we know is that y is equal to negative 36.670 plus 0.119b. Let's copy that over. Okay? So we'll copy that over again. Here it is. You'll notice I wrote y with this little symbol above it. We read that y hat, and that is standard statistical notation. It means that we have a regression equation, an approximation for predicting data. It doesn't mean y exactly equals the numbers that we're going to return. This relationship, or this linear relationship, does confirm what we said in part 1. We thought this data were positively associated. And sure enough, if you look at the slope here, our slope is equal to 0.119, and that's positive. And if that's positive, that means that as x is going up, y is going up, which is what we suspected from the graph. So this linear regression equation actually confirmed what we thought. All right, another important skill you should have is being able to interpret the slope of your least squared regression line, and that's what this question is asking us to do. My advice for doing this is as follows. Take your slope that you have and write it as a fraction over 1. Okay? And then remember the following. That slope always equals change in y over change in x. So this is where you got to keep track of your variables again. So in our case, we go back to the data. X was the number of powerboat registrations, and y was the number of manatees that were killed. Okay, so we keep that in mind. This number on top is the number of manatees killed, and this is saying the number of boats. So now all you need to do is put that into a sentence. What do we know here? If we look at that denominator, that's 1, and the numerator is 0.119. What this is saying is, as the number of boats increases by 1, the number of manatees killed increases by 0.119. Okay? If you want, you could get a bigger denominator for this fraction. We take this fraction and we re-express it. We could write it as 119 over 1,000. We get that by multiplying the top and bottom by 1,000. So we could say it this way. For every additional 1,000 boats that get registered, we can expect about 119 more manatees to be killed by those boats. Okay? Question 4 is asking about the y-intercept of least squared regression line. You'll notice in this case our y-intercept was negative 36.670. Okay? And the key to interpreting y-intercepts is to think what that means. That means that x is 0. It's the only way you can have a y-intercept. So that would mean x, the number of powerboat registrations, was 0. And we get a y-intercept of negative 36.67 manatees killed. And sort of a strange thing to say. We would expect if there's no boats driving around that we would have no manatees killed by collisions with boats. And this is saying negative manatees killed. It doesn't make a lot of sense, really. It's less than 0. I'm happy about that. So what can we say here? We can say that sometimes over the least squared regression lines, if we try and predict things outside the range of x values we started with, then you get answers back that often don't make sense. And if you think about it, our x values for these problems ranged between 1,050 to 1,190. And so we have to keep that in mind. This little word to the wise, extrapolation, is a little bit dangerous. But we'll talk more about that. That's the subject of a different lesson. Okay, thanks for watching. Bye. All right, actually I said goodbye too early. Thank you for watching, of course, but I just want to leave you with one more thought. When you start to look at these relationships and fitting lines to data, the question you should ask yourself is, do you think that these variables are really having effect on each other? In other words, do we think, in this case, that the number of powerboats that are registered in this area of Florida actually has something to do with the number of manatees that we see being killed by boats? So often that's going to call for you to sort of form a hypothesis. Later in the course, we'll learn how to test those hypotheses and so forth, how to build good experiments. For the time being, just keep those questions in mind.